Students, I am Department of Chemistry, General Aspect, B.Sc.lll University. B.Sc. 3rd Sem is concerned. In the last class, we have studied the Carnot's cycle and its efficiency. Now we have to study under this thermodynamics Carnot's theorem. Statement of Carnot's theorem is all reversible heat engines working between the same two temperatures have the same efficiency. That is, the efficiency of reversibly working machine depends only on the temperature of the source and the sink. That is, temperature of source and temperature of the sink, and is independent of the nature of the substances used for operations. Already we have studied the 4 operations in the previous class. So, efficiency of a heat engine may be given by any one of the following expressions. Either it can express in the form of quantity of heat, or it can express in the form of difference of temperatures. As eta, this symbol is called eta, is equal to W by Q2 is equal to Q2 minus Q1 by Q2 is equal to T2 minus T1 by T2. That is difference of quantity of heat in the numerator, quantity of heat in the denominator, difference of two temperatures in the numerator and final temperature in the denominator. So efficiency of the heat engine can be increased by widening the differences in the temperatures of the source and the sink. If the temperature of the source and sink is more, then we are getting the more efficiency. This is a very important concept they are following in the industries. The main aim of the industry is that they are concentrating on the efficiency of the engines. Then they are applying this Carnot's theorem. Then to solve this problem, this equation is required now. The first problem, calculate the maximum efficiency of an engine operating between 110 degrees Celsius and 25 degrees Celsius. We have to calculate the maximum efficiency. Temperature difference is 110 degrees centigrade, 25 degrees Celsius. So given T2 is equal to 110, we have to convert this into Kelvin by adding 273, then we are getting 383 Kelvin. T1, 25 plus 273. 298 Kelvin, you have to calculate the efficiency eta is equal to. So efficiency eta is equal to, you know that in terms of temperatures, T2 minus T1 by T2 is equal to 383 minus 298 divided by 383 is equal to 0.222. I told that always this efficiency is less than 1. In the previous class we have discussed about this one. Or can, if we are expressing this in terms of percentage, it is multiplied by 100, then we are getting eta is equal to 20.2%. It is in terms of percentage. That is, the efficiency of the heat engine is 22.2%. This is the first problem. Second problem, heat supplied to a Carnot engine is 1897.8 kJ. How much useful work can be done by the engine which works between 0 degrees Celsius and 100 degrees Celsius? Melting point of ice and the boiling point of water. Then Q2 is equal to heat supplied is 1897.8 kJ. T1 0 degrees Celsius plus 273, in terms of Kelvin is 273 Kelvin. T2 100 plus 273 is 373 Kelvin. Then formula, we have W by Q2 is equal to T2 minus T1 by T2. We have to calculate the work done here, so W is equal to QT is going to this side, RHS, this coming to the numerator, QT into T2 minus T1 divided by T2. Fill the values. 1897.8 into difference of these two temperatures is giving 100 degrees Celsius. Then the whole quantity, if it is simplified, we are getting the 508.7 kilojoules. This is the W, that is this amount of work, 508.7 kg of work is done by the engine which works between 0 degrees Celsius melting point of ice and the 100 degrees Celsius boiling point of water. Concept of entropy we have to study now. For a reversible Carnot cycle working between T1 and T2, you know that already. Q2 minus Q1 by Q2 is equal to T2 minus Q1 by T2, equation number 1. So simplify this. Q2 by Q2 minus Q1 by Q2 is equal to T2 by T2 minus T1 by T2. So it gets cancelled. 1 minus Q1 by Q2 is equal to 1 minus T1 by T2. This implies that 1 gets cancelled, minus gets cancelled, or minus divided by minus becomes plus. So Q1 by Q2 is equal to T1 by T2. Or you can simplify this by making cross multiplication. Q1 by T1 is equal to Q2 by T2. Equation number 2. Totally, it tells about Q by T is a constant value. That is, Q by T is equal to constant. This is equation 3. Thus, for a system, heat absorbed or lost isothermally and reversibly divided by temperature. This is Q divided by temperature T, at which heat is absorbed is a constant value. This quantity is a constant value. But in a Carnot cycle, Q2 has a positive value since it is at higher temperature, and Q1 has a negative value since it is at lower temperature. Higher temperature means heat is absorbed, lower temperature means heat is lost. So Q2 by T2 is equal to minus Q1 by T1. Take this to the LHS, it is becoming Q2 by T2 plus Q1 by T1 is equal to 0. You can say that sigma Q by T is equal to 0 because this is in the form of a summation. So sigma Q by T is equal to 0. Equation number 4. For infinite number of Carnot cycles, many number of Carnot cycles if they are taking into account, then sigma dq by T is equal to 0. Equation number 5. dq means there is small quantity of heat absorbed at temperature T during small isothermal reversible change in a process. So if the process is taking place in two steps, that is from path A to B and from path B to A, thus sigma dq by T is equal to sigma A to B dq by T plus sigma B to A dq by T is equal to 0. Or you can say that sigma of A to B dq by T is equal to, take this to the RHS, is becoming minus sigma of B to A dq by T. Or you can say that Q by T from A to B is equal to minus Q by T from B to A. So Q by T A to B is equal to minus Q by T B to A. This implies that the total value of quantity Q by T for a path A to B is equal to the total value for the reverse path B to A. Thus, Q by T quantity is a state function, that is, its value depends only upon the initial state A and the final state B and is independent of the path. So it is called the state function. This Q by T depends upon the value of P, B and T, pressure, volume, temperature, and this quantity is called entropy and is denoted by S. So we have to define this. Entropy now, definition of entropy, and this term entropy was introduced by the scientist Clausius. Definition: entropy is defined as the heat absorbed isothermally and reversibly divided by the temperature at which the absorption of heat takes place. This is the definition of the entropy. So, if SA is the value of entropy at initial state A and SP is the value of entropy at final state B, we can write this as SP minus SA is equal to delta S is equal to Q by T, or ds is equal to dq by T. Absolute value, because absolute value of entropy cannot be determined. You can determine this entropy in the form of final state and the initial state. So change in enthalpy, change in entropy is given by delta S is equal to Q reversible by T is equal to dq reversible by T. We can say, and in the examination they ask this definition entropy for 2 marks. We have to say that this entropy is a state function by this explanation. Change in entropy depends upon the initial and final states of the system and not how that change is brought about. Whatever the path forward for this change, but we have to concentrate mainly on the from initial state to final state. This change in entropy, delta S is expressed as, already we have studied this one, delta S is equal to SP minus SC is equal to summation of S products, entropy of the products minus summation sigma of S reactants. This difference also gives the change in entropy. If Q reversible is the quantity absorbed by the system during change. Then you can write delta S is equal to Q reversible by T, or ds is equal to dq reversible by T. So entropy is a state function. So this is the explanation for the entropy is a state function. And they will ask an examination for 2 marks along with the definition unit. So what is the unit of this entropy? You know that this quantity of heat is in terms of joule, temperature in terms of Kelvin, and it is present in the denominator. So unit of entropy is equal to joule per Kelvin, and for 1 mole you can write this joule per Kelvin per mole is the unit of the entropy. Thank you one and all.